So in this video, we're going to talk about the fundamental counting principle. So in order to count the number of ways we can perform a given task, number one, determine the number of steps. To complete the task. Okay? So determine the number of ways to complete the task. So in the last video, I introduced a probability experiment where we, let me undo that, where we rolled a die and then we flipped a coin. Okay? So to determine the number of ways to count out how many total outcomes there are, which we found to be 12, let's think about this. There's how many steps in rolling a die and then flipping a coin? There's 2 steps. So roll die, flip coin. So 2 steps. Now, step 2, count / determine the number of ways to complete, bless me, each step. Okay? So how many ways can I complete each step? So whenever I roll a die, okay, so I draw lines, I draw 2 lines, represents my 2 steps, right? How many ways to roll a die? Well, there are 6 ways to roll a die, so I have 6 ways to complete the first step. And then how many ways to flip a coin? Well, there's only a heads or a tails, so it's only 2 ways to complete that task right there, okay? And then step 3 is the total number of ways to complete the task is, and what do? I multiply. So I multiply 6 times 2 to get me 12. Okay? Multiply That's all you do. All right. So the reason this is a powerful counting rule is because sometimes it's really hard to list out, like we did in this example here, there were only 12 outcomes. We could do a tree diagram and just list out all 12. But what if there's like 24,000 outcomes? Okay. Do we want to sit there and list out all 24,000? I don't think so. So the fundamental counting principle takes that very complicated problem and listing them all out and breaks it down into 3 steps. Step 1, figure out how many steps there are, and for each step I put a blank. Step 2, figure out how many ways to do the individual steps. Once I get those numbers, then when I have all those numbers, I multiply them together, and whatever that multiplies to, that's how many ways to accomplish the task. So let's run through an example. So we've got passcodes to cell phone is 4 digits. So like you're gonna type in your code to your cell phone. So your cell phone's like 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you got a 0 like that on your passcode. And so it can be any of those 0 to 9 digits, but there's 4 digits, okay? So maybe your code is 1111, right? That's a really complicated code, right? So maybe it is, maybe your passcode's a little bit better than that, right? So how many passcodes are possible when you can repeat digits? So this would be an example where I can repeat digits, okay? So we go back to the counting principle. And the counting principle says that step one is I figure out how many steps there are. Well, if I'm going to press a button 4 times to make a 4-digit number, that means there's 1, 2, 3, 4 steps, okay? How many ways can I press that first button? Well, there are 10 digits to choose from, so there's 10 ways. Now, how many ways to press the next button? Well, if I can repeat digits, that means that I can use the same one over and over, right? So there's still 10 options on the second button, 10 options on the third button, and then 10 options on the fourth button. And now that I have all the different ways to complete the steps, I multiply everything together. I get 10 times 10 times 10 times 10, which is 10,000. So there's 10,000 possible codes. That's a lot of codes. Now, say you did a passcode that had 6 digits. Not only would that be really hard, it'd be almost impossible to guess, because then at that point there'd be 6 zeros, would make it 1 out of a million chance to get it instead of 1 out of 10,000, assuming you can repeat it. Digits. Now, what if you cannot repeat the digits, meaning that 1111 can no longer happen? So the next code you could get would be like 1, 2, 3, 4, right? So none of those digits are repeated. So how many steps? Step one, figure out how many steps. Well, if I've got a 4-digit code, that means I'm doing an action 4 times. So there's 4 steps. I think of it as actions. Flip the coin, roll the die. 2 actions, right? Press the button to a 4-digit code. I press a button 4 times. That's 4 actions, 4 steps. Now, if digits can't be repeated, on the first digit I choose, how many did I have to choose from? I had 10 options. But once I choose that digit, can I choose it anymore? No, I cannot. So that leaves me with how many digits left to choose from? Only 9, okay? So there's only 9 left to choose from. Then on the next digit, so say I choose a 2, right? Well, then how many does that leave me with? That only leaves me with 8. And say I choose a 3 for the next one, right? Then how many does that leave you with? That only leaves you with 7. So now, if you can't repeat digits, you have 10 times 9 times 8 times 7. And if you multiply that out, you get 5,040. Okay? 5,040 codes. So what are you noticing? The more restrictions you put on it, you cannot repeat it, then that means that you have less options to choose from, okay? Because not only do you not have this as an option, you can't have this as an option either, because the 1 repeats, okay? So it knocks out a lot of numbers. Specifically, it knocks out 10,000 minus 5,040 numbers, right? So 10,000 minus 5,040, which is knocking out 4,960. So that's how many codes. Now you can't pick those codes anymore, right? Okay, so the last one says cannot be repeated, and the first digit is non-zero. So there's still 4 digits, so 1, 2, 3, 4. All right, now digits can't be repeated, but the first digit is non-zero. All right, so we've got a passcode of 1, 2, 3, 4, 5, 6, 7, 8, 9, and then a 0. And it says can't be repeated and the first digit non-zero. If the first digit is non-zero, that means I can't put a 0 for the first one, so I have 9 digits to choose from. Okay? So I have 9 digits to choose from on the first one. Now, on the second one, okay, it says digits cannot be repeated, okay? So maybe I picked a 6 for my first number. I don't know. I just picked a 6, okay? But it doesn't say anything about being non-zero for the rest of them. It just says the first digit can't be non-zero. So what does that mean? Now we can actually use a 0. So how many options do I have? I got 1, 2, 3, 4, 5, 6, 7, 8, 9 again. So I have 9 here. But say I pick like a 9, I don't know, let's not to be confusing, let's pick like 3, okay? So now I picked 3. How many digits do I have to choose from? That gives me 1, 2, 3, 4, 5, 6, 7, 8. So now I have 8 digits to choose from, okay? And then, so maybe I pick like the digit 2 or something, all right? And I can't repeat digits, so now I only have how many to choose from? 1, 2, 3, 4, 5, 6, 7 digits. So there's only 7 digits there. And so maybe I pick a 0 on this one, whatever. Okay, so that's a possible combination. One of many. How many? Multiply them out. What do you get? 4,536 possible codes. Okay? So not as many as before, but still a good number. Okay? So the more restrictions you put on it, your passcode, the less passcodes you have to choose from. So here there were none. You could repeat digits, whatever. Here I said you can't repeat digits, and the last one says can't repeat digits, and I put on another restriction. First digit can't be, or first digit is non-zero, so it can't be 0. So I got rid of several more, okay, codes because of that first digit being non-zero. All right, so hopefully this helps you understand more the fundamental counting principle. Determine the number of steps, okay? With that passcode, there were 4 steps because you did 4 actions. You pressed 4 buttons to break into the code. Step 2, figure out how many ways to do each step, okay? So there were 10 digits to choose from, and then if you couldn't repeat digits, then there were 9, then there were 8, then there were 7. And then once you have all those numbers, you multiply. And whenever you multiply, you get how many ways there are to complete the task.